So I'm going to combine a couple of sections here, 5.2 and 5.6. So the 5.2 is about sampling techniques. 5.6 is about bias. Okay. So sampling techniques, sampling, it's all about how do you collect your data? Okay. How do you sample a population to get information that you need? Okay. And this is usually typically in the form of a survey. So, you ask questions and you get responses. And sampling techniques are a way to just, kind of how do you pick the people you're going to survey. Okay, so sampling technique, more formally, it's the method used to select a group from a population you wish to study. Okay, so a population could be an entire country, could be a city, could be a province, it could be just people in a building, or even a small community. So a population are all the individuals or items being studied, and we usually take a sample of the population. So sample is the group of people or items that are selected from the population to be studied. So that sample, after you do your survey on a small group of your population, called that sample, is supposed to be representative of that entire population. And sampling frame, so the members of a population that actually have a chance of being selected for a study. And our last definition or terminology here is statistical bias, which is the systematic error in a survey or sampling method which favors certain outcomes. Now, let's go over some sampling techniques here. So we have two categories, some that are random sampling techniques and others that are non-random. And so in a random technique, every member of the population has an equal chance of being selected. And for non-random, well, this is not really the case for a non-random sampling. So random sampling, simple random sample. That's the first kind of sampling technique that we're going to study. So it's the most common one, simple random sample. So randomly select individuals or items to study. So how do you pick something randomly? You can draw numbers out of a hat, use a random number generator. As long as it's random, there is no pattern, right? There's no pattern to how you select people. It's completely random. The next type of random sampling technique is a systematic sample. So this puts the population in an ordered list and selects members at regular intervals. So, like, say every nth person or every fifth person. So imagine a long lineup, and you are, let's say, a long lineup to get into a movie theater, and you are there conducting a survey, and you're asking every fifth person on the line what's their favorite movie. That's an example of systematic sample. Stratified sample. So this is the technique where you divide your samples into groups proportional to those groups in the population. Okay, so it kind of gives you the best sample, but it can be difficult to design or execute. So what's an example of this? So imagine groups. It's all about grouping. So imagine a high school, right? So what kind of groups can you make in high school? You can divide your population by grades. So you can sample members from each grade. Okay, that would be stratified. Okay, and then you have cluster sample, which is not too different. So a cluster sample divides your population into groups as well, but it actually randomly selects certain groups to study every member in the group, not just a random number or random sample of that group. So if a stratified sample would be something like, you have 4 different grades from grade 9, 10, 11, and 12. Instead of surveying every grade 9, 10, 11, and 12, you'd pick like maybe 20 grade 9s, 20 grade 10s, 20 grade 11s, and 20 grade 12s, right? You're just taking a small sample of each group. But in a cluster sample, you have to think about it carefully. So in a cluster sample, you have to, like, let's say, imagine you're in the cafeteria having lunch. Each table could be a group. And what you'd be doing is you pick, let's say, 3 tables and conduct your survey with every single student in each of those 3 tables. Okay. Multi-stage sample, so divide the population into a hierarchy, meaning like there's a certain level or rank, and choose a random sample at each level. Okay, so groups are specifically defined. So imagine maybe, let's say, in a company, you have management, you have workers. You can conduct surveys between each of those different groups. What about some non-random sampling techniques? Well, you have convenience sampling. So this is something that you select data because it's easy to access. So if you're going to do a survey and find some data on people's shopping habits. Or you go to where you would conduct a survey, where you can go to the mall, right? That's where people shop. Or maybe you're conducting a survey where it's just easy to ask your class or your friends questions because they are right there accessible to you, right? So easy access to data is the key thing here. Judgment sample. So researchers use their knowledge or judgment to select individuals or items. So you may ignore certain characteristics of the population intentionally. So you're kind of using your own judgment, which could be, have some bias in it. You're prone to spin your point of view one way or the other. So keep in mind these two techniques so far. These are non-random, right? They're not randomly. You're actually choosing, right? You're choosing your own sample. Number three, voluntary sample. So this is participatory. So think about, it depends on not who the person, not you conducting the survey, but rather the participant trying to respond to you. Depends on if they want to volunteer that or not. So think of, like, let's say the popular TV show American Idol or Canadian Idol. You put on a bunch of contestants and they all sing for you, and you have to actually vote to pick which one you want. That's an example of a voluntary sample. So it's not someone actually surveying you, asking you who should be advanced to the next round in the competition. It's actually people phoning in or texting in their responses to you voluntarily. Other examples would be like asking people to submit a comment card at a restaurant. How's the service, that kind of thing, or an online survey. Let's go through some examples. So for each situation, identify the type of sampling technique used. So the first one, you want to find out if your town is in favor of starting a composting pickup service. You ask everyone on your street. So the fact that you ask everyone on your street is very convenient. So we're going to say that's a convenient sample. Part B, a university is polling students. It selects 200 students at random in the sample in the same proportions as the enrollment in each department. So that's an example of a stratified sample. There are 139 swim clubs in Ontario. Swim Ontario conducts a survey to vote on its new logo. The organization randomly selects 10 swim clubs and surveys each member in each of those clubs. That's an example of a cluster sample. Because you have 139 groups, so you're grouping them by clubs, right? And then you select 10 of those groups, so 10 swim clubs, and you survey every member in that club and in those clubs. A coach puts the names of all basketball players into a hat and draws one name for free basketball. Well, that's just a simple random sample. A questionnaire is sent to every ninth person on an alphabetical list of a store's credit card customers. The first person chosen from the list is picked randomly. Systematic sample. So every ninth person means you're skip counting, right? You're systematically choosing every ninth person. The student council invites all students to provide ideas for activities. So this is voluntary response sampling. So it's not like a student council is going out there asking each individual person, what's your idea, right? So what's your idea, right? No, you're just, let's say, putting it on an announcement on the PA system, and you're inviting students to provide you ideas, maybe write a comment card or something like that and submit it to the student council. A marketing firm wants to collect information on certain products in a city of 800,000 people. The researcher randomly selects 10 neighborhoods. In each neighborhood, they randomly select 5 streets. In each street, they randomly select 10 households. So kind of a multi-stage approach here for sampling. So, you're going at different hierarchies. You're going from the neighborhood to the streets to the households, right? Okay. Example 2, designing a systematic sample. A telephone company is planning a marketing survey of its 760,000 customers. For budget reasons, the company wants a sample size of about 250. Suggest a method for selecting a systematic sample. So if your population size is 760,000, you want to choose 250 people that represents that population. Well, the ratio population size over sample size is going to be 3,040. So for every, basically one person out of the 250 will represent 3,040 people in your population. So the idea is to create a systematic sample. Well, you call every 3,040th customer on the list. Example 3, before booking bands for the school dances, student council wants to survey the music preferences of the student body. The following table shows the enrollment at the school. Design a stratified sample for a survey. So you have, again, stratified, meaning you have to group your population somehow. So in the school, the good way to group them is by grades. So grade 9, grade 10, grade 11, and grade 12. You don't have an equal number of students in each one, but you want to kind of do 25%. So if 25% plus 25% plus 25% plus 25% add up to 100. So if you get 25% of each of your population, you randomly select 25% of each group, you'd get a fairly balanced sample. So this means we're going to do 64 grade 9s, 58 grade 10s, 52 grade 11s, and 46 grade 12s. Again, the idea is to get an equal proportion of your representative groups, right? So if you didn't do percentages, if you did like 20 people from each grade, it wouldn't work because 20 people out of 255 is less representation versus 20 people out of 184, right? So you have to be very careful. You can only pick by people if each of your groups have the same number of students. Okay, so um, okay, so here, excuse me. So here we have the number of people. So if we total up this, we have 220 people, but 220 people might be difficult to survey. So if we scale down the number of people down to something out of 100, we can get something more manageable, right? So 29, 26, 24, and 21 on 100. So this is just basically taking a proportional ratio of turning this number into a number out of 100. Okay, so that's the first part of our lesson, sampling techniques. The second part is bias. Okay, so bias occurs when the characteristics of the sample are not representative of the population. Okay, and bias can come from the sampling method or it can come from the actual survey questions that you ask. So you have to consider when you're looking for data, you want to get the best sample of data that represents the population that you're studying. Okay, so here's the kinds of bias that you can encounter. So you have sampling bias, a bias resulting from a sample that does not adequately reflect the characteristics of the population. So a kind of like non-random sampling method being used. So what's an example of this? If you're not if you're surveying if you're interested in finding out information about let's say driving habits, okay, let's say driving habits of people, but who do you survey? Maybe for convenience, you just survey your friends. Well, that wouldn't work. They wouldn't represent the population because your friends most likely are just barely getting their driving licenses and don't have any driving experience. So keep that in mind when you're asking your survey, because you don't want to be asking people who don't represent your population. All right. You can also have survey bias. So what? So let's go number 2 over here. So measurement bias. So bias resulting from data collection methods that consistently either under or overestimates a characteristic of the population. So if you fail to calibrate your tools, your ranking system is not defined, or your question is unclear, it can result in your measurement bias, right? So, like for example, if you're measuring, let's say you're in a manufacturing line and you have to measure whatever tools you're creating. So you're creating a product, it has to be within the specified measurement. And so your tools have to measure that, and you're collecting your data. And if your tools are not calibrated right, then you might get bad readings. Okay. Or if you're ranking something, 1 low, 10 high, that's an example of not having a good. You have to make sure you have your ranking system being well defined, right? What is the meaning of low? What's the meaning of high? That's another thing too to consider sometimes, depending on the context. Okay, and so that's some bias could happen when you're sampling methods. So you have to keep that in mind. You want to make sure your sampling methods are random as possible and representative of your population. All right, survey bias. So what can happen when you actually conduct your sample and you ask that survey question? Well, you could have a leading question, a form of a measurement bias, which use questions which prompt a particular answer, such as multiple choice options. So some examples are, yeah, you give a question, you have four multiple choice. What's your favorite color? Blue, yellow, green, and red. Four answers, choices. So they're forced to pick from blue, yellow, green, or red. But what if their favorite color is black? It's not there. It's not gonna, you're influencing their answers to pick one of the four that you're providing them. So you don't want to pressure your respondents that way. It's going to cause bias. You're influencing their answer. You can have a loaded question, so a form of measurement bias which uses questions containing information or language intended to influence a response. So strong wording often provoking an emotional response. So providing a information inside your question. So for example, let's say if my question was, uh, suppose eating bananas are known to be really healthy for you. Do you eat bananas? So the survey question would be like, do you eat bananas? Yes or no. But if you load that question with uh, uh, some wording that suggests that maybe you should be answering yes, then you're kind of, yeah, you're influencing the answer. So you're creating some bias. Um, yeah, right. Response bias. So bias that occurs when participants in a survey give false or misleading answers. So you're asking questions that are not really worded nicely, so people are not sure how to respond, or maybe they are sensitive questions. People often say, well, you shouldn't ask someone how much money they make because they won't really want to be truthful about that. Right? So they're either embarrassed to reply truthfully or they don't want to talk about something personal. Um, or if they're rushing through a survey, sometimes you're forced to do a survey and you don't want to do it and you just rush through all the questions. So you could have some response bias, meaning people may lie. Okay, they will lie. Then you also have non-response bias. So bias occurs when particular groups don't answer the survey, right? Or they don't complete certain questions. They leave them blank, which again affects your results. So be very careful there. So let's go through some examples here. Identify the type of bias. So survey question asks, how many words per minute can you read? So it's a response bias. Many people don't want to admit to them reading slowly, so they may not know or they're too embarrassed. So again, another thing, if they don't know how many minutes they read, then how can they answer that? So uh, that's an example of response bias. Survey is sent to parents of school-aged children that ask whether bus safety lanes should be installed. So it's a sampling bias. So more than just parents drive on the roads. So you're asking only parents of school-aged children, right? So of course they're going to be interested in having safety lanes, bus safety lanes, but which could be really uh, detrimental to the traffic flow of everyone else driving on those roads. So I mean, you have to like ask. As one consideration, it could be other considerations too, costs and everything like that. Taxpayers have foot the bill. Be very careful with things that you ask and people you're asking. So um, this is an example of sampling bias. Number C, a phone company surveys its customers via text message about which services people like the best. So non-response bias, only those who feel strongly either way may respond. Right. So people may not care and may not respond. So you could get non-response bias. So you have to create a survey that encourages people to respond. Maybe you can include like oh, you get $1 off on your next bill if you respond to the survey. Something like that. You have to think of little tricks that you can do. Survey question asks, now the city is in debt. Do you think the current mayor will win in the next election? So again, loaded question. You're introducing an idea here that will influence their answer, right? So the question should be, do you think the current mayor will win the next election? Yes or no? But if you add this first clause, now that the city is in debt, you might think, well, this mayor he gave us all his debt, so why should we re-elect him? So you might influence their answer to say no, and that's a problem too. So you don't want this kind of bias in your data, right? That's really bad. Survey asks, what's your favorite make of vehicle? Ford, Honda, Toyota, or Chevrolet? So again, leading question. You only have four choices. What about the alternatives? Okay. So here's another example. Explain how each case uses misleading or questionable statistics. So the Daily Mirror and the Times retweeted this tweet about a British high-speed rail project that is expected to take 20 years to complete. So here's the statistic: 93% of today's UK population will be dead by the time the HS2 is finished. Wow! Hashtag BBC QT. So this suggests that it will take only 20 years for the 93% of the current population to die. This would imply that in 20 years, the oldest living people would be in their 20s to 30s. So again, misleading statistic, uh, and they're using it to maybe say that there's something bad about this project. So I mean, like you look at 93%, wow, that's big, right? But no, I mean, you look at the actual demographics, then you can get a better picture. In 2005, the British Cheese Board conducted a study to show eating cheese does not give you nightmares. So here, no details are given about the data collection method. Also, wording is kind of awkward. So it's like does not give you nightmares. Like, okay, well, I mean, if you read that thing, it might seem awkward to begin with, right? So what's the connection? Uh, so again, when you're doing studies, you do have to provide your data. You have to show people how you did your data collection method, so they can duplicate that and see if what you did, the work that you did, is valid, right, and not prone to errors or bias. Here, part C, the newspaper report about a survey asked, did scientists falsify research to support their own theories on climate change? And shows the following summary: 59% somewhat likely, 35% very likely, and 26% not very likely. So again, if you're not looking carefully, you'll notice that these three numbers don't add up to 100%. They add up to over 100%, which isn't possible. So there's something going wrong here in their data collection and their numbers. And perhaps maybe people are answering more than one answer. That could be another thing too. Part D, research shows that if you eat a sausage a day, your risk of certain type of cancer goes up by 20%. Again, no details are provided, no statistics. There could be other factors. Maybe those same people they studied who got cancer, maybe were exposed to something else, right? Maybe not, may not be the sausage. So it's just something to consider. Okay. So that's the end of this lesson. I didn't, I put all the notes up on the screen first because it is a lot of writing. So I didn't want to make the video very long, but I want to keep it as short as possible. So you may have to pause the video during certain times to get information. And that's it for this section.